in our third meeting in laboratory introduction to automation. My first question is, do you hear me? Yes, it's good information. So uh, today and yesterday, uh, you sent to me a few reports about 3 or 4 reports. So for today we have a deadline, yes, to do it, and for today a next topic related with us with different aspects in automation. So today I would like to send you an interesting scientific work. So okay, I sent to you a PDF file, catalyst mixing problem, and your task is to read paragraph 5.1 and try to understand it. So hopefully 15 minutes should be enough to read and try to understand this paragraph. So we will be continue in 15 minutes. Ladies and gentlemen, now we can continue, and I would like to talk with you about this. What did you read during this time? So, would you like shortly talk? What did you read in this time? So, in the other words, in paragraph 5.1, we can see a few equations. What are the numbers of these equations? Yes, I understand, but um, I understand that you may not understand this text because it's quite difficult. But I would like to ask you one more time. What are the numbers of equations which you can see in this text in paragraph 5.1?
We have x1, x2, and x3, and then we have the initial conditions of those values.
Okay. So, uh, Ladies and gentlemen, slowly, slowly. What are the numbers of equations? 43, 34, 35, yes? 6, 7, 8. Do you understand? In the brackets. Yes, because we have in this situation 1, 2, 3, 4, 5, 6 different equations. And the most important thing is this relation 33. How to read this text? We need to find a value of u, but we need to find this value of u in this way that the value of x3 at the end of the process should be maximized. Okay? We need to maximize value of x3 at point 1.0. And to maximize this value, we can use u. And our process is described by two differential equations and one algebraic equations. So we can observe that if we would have x1 and x2, we can obtain x3. Moreover, we have initial conditions. For beginning is at time 0 to 1. It's duration time of our process, and x1 at the beginning is 0, x2 is x1 is 1, x2 is 0, and x3 is 0, and we can try it. 1 minus 1 minus 0 is 0, and this is true. And we have our equations, we have initial conditions, and we need to find a control function which is between 0 and 1.0. This function can be varying during the time, but now I would like you to assume that u control function is constant in the time. So if we choose a value of u and we have initial conditions, we can solve this system of equations. And after that, we can plot our solution and compute the value of x3 at the end of the process. And my question to you, did you understand what I'm talking about? Yeah. Plus minus. So, and my question, do you have MATLAB or not? Yes. So now I would like to make with you a short project of this problem, how to solve this task. So uh, um, so my question to you, what do you see just now?
Paint.
Paint
The thing. The equations.
and equations. Okay. So so I would like to do with you a short project of your program in MATLAB. So now we start with a function function a general function. For example, it's our third meeting, laboratory third. And function end. And now we have T-span. It means the domain where a domain where our problem is solved from 0.0 to 1. Now our initial conditions, because we have two differential equations, we need only two initial conditions, and the third one in practice is computed according to this equation. So, and to simulate this process, we need to assume a value of u. And then we can solve this system using a function, for example, order 45. Yes, but here, like previously, we write this, but a little bit later. Now, I would like to write a system of equation function the same like previously, and the X, it's model catalyst mixing problem. So we can use it. The X is equal to and the X zeros to 1 and the X1 is equal, according to this equation, U dot then X2 minus X1 the same this, but this equation, and at the end we can write that X3 is equal to 1 minus X sol all rows first column minus X sol all rows second column. Then our solution is the value of X3 at the end of the process. So, moreover, you can plot the solve Okay, it's clear for you? So now I would like you to uh, implement this in MATLAB, but uh, in case of emergency, we will be continue this in 20 minutes. So you can make a print screen of this. Okay, and try to implement it. And in 20 minutes, I we, we can do it together in case of any problems. Uh, so my first question, uh, do you have any solutions? Okay, so maybe I try to uh, make a solution. So do you see my MATLAB? Yes. So uh, first we make a function. You can see if it's working. It's working. So uh, you write this span, then zero, initial conditions, then our u, for example, this, and is equal to, Now we make our system of differential equations. First equation, second one, x1, then x2 minus 1 minus u times x. Hopefully it's enough in this part. Oh, it's wrong. No, it's good. So, firstly, we write at time and after time state variables. So it should be so. Now it's good. Mm. We have a plot. And our final solution is x3 at the end of the process. So we have the first trajectory x1, x2, x3, and here we have a value for this u of x3 at the end. And now the last thing what we can do is the part related with optimization. Process optimization. So if we give the other value of u, we have the other solution. Therefore, we can try different values of u equal, like in this example, from 0.0, a small step to 1, u is equal to small u, and is equal this. And after that, we can make a plot when we have different values of u and obtain values of x3. So here we have different values of u between 0 and 1 and the obtained values of uh, x3 at the end. And now we can observe where for each u the objective function is the best. Oh, this point. So this is our work for today. Mm, it's for you, and yes, uh, and hopefully for today it's really enough. The work for you is uh, three things: a report from this meeting, then some of you sent to me your reports, but the PDF file were unsigned. Well, therefore, try it one more time and send me signed reports, yes? And the last thing, and the last thing, happy Easter. Uh, be healthy and be careful, and hopefully we will meet in few weeks together uh, to talk and to implement some algorithms related with automation, automatic control, and control theory. So for today, thank you for your attention and happy Easter.
Happy Easter. Goodbye.